we're going to create a correlation matrix using a data frame. So the first thing I'm going to do is set the working directory to where my data is saved using the using the choose directory option. Okay, so I've set my working directory. Next, we're going to import a couple libraries. The first library that we want is CorePlot. And the second library that we want is called Performance Analytics. If you don't have either of these libraries, just use install packages and install them. So it's just this function here. And if you didn't have either of these libraries, you could just take the name and install it just like this. Very simple, but I already have both packages installed, so I'm not going to do that. Okay, so the next thing that we need to do is import our CSV data or whatever data frame you're working with. At this point, you might already have your data frame in your working environment, but I don't. So I'm going to import a data frame. I'm going to call it df, and I'm going to call the read CSV function to import my data frame. There we go. And we can take a look at the first 6 rows by using the head function. You can see that I have a lot of raster bands. I converted a lot of rasters into data frames. I merged them together, and this is what I'm working with right now. I also have a lot of vegetation indices, also calculated using raster data. So we're going to jump right into it. The first correlation matrix we're going to make is just a table of correlation coefficients. I'm going to call it CoreDF, and it's the core function from the CorePlot library, and this will create a data frame of correlation coefficients. So let's run that. It's core, and then the argument that it takes is the name of your data frame. So we have that. Let's take a look. And there we go. So you can see the correlation between all variables in the table. We can ignore the X column. We don't want that. But everything else, you can see the correlation coefficients. Obviously, there's going to be one value of 1 in every column because, you would assume that the variable is very highly correlated with itself. So for instance, B12, when it's next to B12, it'll have a correlation coefficient of 1. So that's that. Now, this is, a lot of good information, but often the best way to assess what's going on in your data is by visualizing it. So we're going to create a correlation plot using the CorePlot function. So the function is CorePlot, and they don't want just the raw data frame. So they don't want df, they want the table. So we're going to use CoreDF in our CorePlot. And then from there, we need to specify a method. And I'll include a link in the description to where you can see all the different methods available. But for now, for the first plot, we're going to use the number method. And this is where they actually display the correlation coefficients in the chart. And then we're going to order them by the alphabet. Let's run that. And there you go. So right off the bat, you can see that the numbers are kind of overlapping, and that's because I have a lot of values. Let's zoom out a little bit. You can see a lot of the values are quite high, and that's because we're dealing with raster bands from the same satellite. These bands are very close to each other, similar spectral values, and that's why they're highly correlated. And it's just a really easy way to assess which values are correlated and not correlated. So, like I said, the method that we chose was number, where it displays the correlation coefficient. If you don't want the number and you just want to see colors, there's a argument you can use called color. And with that, you get just a matrix of different colored squares representing the coefficient value. The default, if you didn't include any arguments, looks like this. Core plot, it'll be core DF. You can see you get a series of circles, which is, again, a really nice way of assessing what you're working with. And I believe that the colors represent the positive or negative values. So the red orange colors represent a negative correlation coefficient, the blues represent a positive, and then the size of the circle is representative of the strength of the correlation, or the degree of the magnitude of the correlation. So that's a really easy default method of getting a correlation matrix built. Okay, I'm going to show you one more type of correlation matrix. The second type uses a function from the Performance Analytics library, and it's just one function. It's the chart dot correlation function. Just so you know, when you have the library imported like this, a lot of these functions will just start popping up automatically when you start typing, and this is just a helpful little trick in RStudio. So yeah, you can see a lot of the functions available to you just by typing out a few words, and but this only happens when you have the library imported like this. So yeah, that just a heads up. So we're using the chart correlation function. The first thing you need to provide it is the data frame. So for us, it's DF. And we're going to include a couple arguments. First, we're going to include whether or not we want to see a histogram. And I think that's one of the better features of this function. So we're going to say histogram equals true, which means yes, we want to see a histogram. And then I want to see a simple Pearson correlation coefficient. So I'm going to set the method to Pearson. And that's that. Let's run it. Okay, so there is the first plot, but you can see there's a lot going on here. Too much in my opinion. So let's make the data frame a little bit smaller, and then we can take a better look at this plot. So I'm going to create a second data frame, which is just a cropped version of the first data frame. I think I'll just keep 3 or 4 columns. So I'll set the indices to 2 to 6. So we'll keep 4 columns. And then let's take a quick look at that. Perfect. And then we'll redo the plot. And there you go. So there's a lot going on here. Let's go through everything step by step. We have 5 variables, and those 5 are the ones that we included here. We have these plots underneath. These are bivariate scatter plots between each combination of variables. So let's go through this. This plot here is a bivariate scatter plot between cover code and NBR. NBR stands for the normalized burn ratio. We have one underneath one underneath that plot, which represents the scatter plot between the cover code and NDMI. So you'll have to look at the variable that's directly perpendicular to the plot to figure out which variables are included. And there's also a line of best fit. So this scatter plot here, if you can see my mouse, that's the bivariate scatter plot between NBR and NDMI. NDMI stands for the normalized difference moisture index. Now on the other side of the plot, we have the Pearson's correlation coefficients, which are these numbers. The size of the numbers are based off of the magnitude of the correlation coefficient. And then you also have these stars, these red stars. And those are indicators of statistical significance. And the number of stars represent the p-value. I'll include a link that walks you through what 1 star represents, what 3 stars represent. But the more stars, the smaller the p-value, which means it's more statistically significant. So there you go. There's another plot that you can look at. If you want to export it, you can save it as an image or a PDF, or you can copy it and put it in a presentation if you'd like. But yeah, those are a couple of correlation matrices that you can work with, and good luck.